Hey folks, it's me, Mr. Tuttle again, here to talk about the guided notes for section 10.2. So in this first video, I'm just going to cover the first page, which looks like this. Starts off with a few paragraphs with some fill in the blanks, so I'm just going to read those, and then you can fill in the blanks accordingly. Here's how it goes. So there are two different ways to use mathematical symbols to say the square root of x. The common way that most people learn is this, right? That's the square root of x. That's typically the way people are introduced to the square root of x. Another way, though, a more kind of fancy way, is to use a rational exponent, rational in this case meaning a fraction, okay? So in other words, you can use an exponent that is a fraction, yes. So what this means is the square root of x here has another meaning, and that other meaning is this, x to the 1/2 power, right? So it might seem a little weird at first to think about fractional exponents. They don't randomly come out of nowhere, though. Fractional exponents start to make more sense if you recall the rules for multiplying expressions that have common bases. Remember, when you multiply two expressions that have a common base, you add the exponents. Take a look at the examples below. So this is a pretty basic review, but when you have something like x squared times x to the 5th, those bases are the same. X squared times x to the 5th equals x to the 7th. 2 plus 5 equals 7. Okay. Y to the 12th times y squared equals y to the 14th. Great. And then the same rules apply even when you have negative exponents. So z to the 4th times z to the -1 equals z to negative. No, that's not right. I multiplied the exponents. You're not supposed to do that. Z to the 4th times z to the -1st is actually z to the 3rd. You thought I was going to make a mistake there? You were wrong. Okay. Now the same rules apply for fractional exponents, right? So the rules do not change even though the exponents become fractions. So if I have x to the 1/2 times another x to the 1/2, well, same bases, add the exponents, 1/2 plus 1/2 is x to the 1st, which low-key is just x, okay? What about 1/3? I mean, I don't even know what x to the 1/3 necessarily means, but if I have y to the 1/3 times y to the 1/3 times y to the 1/3, well, I don't have to really even know what it means to say y to the 1/3. All the bases are the same, so I just have to add the exponents. 1/3 plus 1/3 plus 1/3 equals y to the 1st, or low-key, just y, right? And then the last example, 1/4, again, I don't even know what it means to have 1/4 as an exponent, but I know how to add fractions. One-fourth plus 1/4 plus 1/4 plus 1/4 equals z to the 1st, which, say it with me, low-key, it's just z. Okay. That is a wrap for page number 1. See ya.